The question I'm getting mostly these days is how to easily implement OAuth. OIDC OAuth became now even more relevant these days, despite that it's very old, 2 decades at least old protocol. At this point now, it's a de facto authentication protocol for the new AI agents and MCP servers also. So it became even more important now. All the big SaaS services that you access daily from your browser across the globe, most of them use this protocol as a standard way to authenticate you. The problem now for your application on any new applications or small MVP application is mostly the blocker is for the understanding of how to implement, because along with the security comes complexity. If we look at the stats, basically most of the compromises are coming from stolen credentials. And what are these stolen credentials? These web tokens. Web application is the weakest chain in the link. In terms of intranet, you have very good security because most of them give you a stateful type of security. You have Kerberos, Active Directory, all those solutions give you a stateful security. But when it comes to HTTP applications, those are stateless applications. Implementing a secure protocol similar to Kerberos, it is complex. So there is a need for a proper protocol, which is OAuth. OAuth basically bifurcates your all login and authentication related issues to a separate service, which is basically an identity service. So it gives you basically pre-authenticated traffic that lands on your front end, back end. So it takes on all the attacks also related to identity. It have complete comprehensive privilege management also built into it, MFA, password policies. So this is the beauty of OAuth. So your main service is separated out and is not facing all those issues with the login, and both either related to performance as well as security. When it comes to simple application, when there is no auth, you have to have complete IDM. Now mostly these new cooked MVP applications or new grown-up startup applications, they don't have complete identity management. If they have some password policies, they might not be having a list of all the bad passwords used across the board which are getting hacked and disclosed. And then if they have one protection, they might not be having CSRF protection or XSS vulnerabilities. There's a ton of token vulnerabilities also, the type of algorithms being used. So having a dedicated service which handles all of this is always a good idea. OAuth gives you that. So when talking about the vulnerabilities, there are so many actually. I've listed some of them, and then some benefit of the secured one. When we talk about OAuth, basically it's a 2 decade at least old algorithm. It came around 2005 actually. Then we have OAuth 2.0 in roughly in October 2012, and it was then we had 2 RFCs on top of it, because then there was a need for an algorithm to secure the front end. So there was a PXE extension, and then there was another need lately for the dynamic client registration, which became very relevant these days now and getting adopted for the AI agents. So now you have OAuth 2.1. So most of the application these days, they use OAuth 2.1. They have both of these RFC extensions for the dynamic client registration, and then with the PXE flow. What exactly PXE is and the dynamic client registration, we'll talk about that. However, when we are talking about that, be noting that OAuth 3.0 is also something in development. It's mostly around decentralized identities. Azure Active Directory also supports, by the way, this decentralized IDs, but adoption is still not there as much as it should. So this thing is in progress actually. So right now, the algorithm that we talk about, protocol OAuth 2.1, is the de facto standard for now. So when we talk about PXE, basically there was a problem with the OAuth in being able to hijack your app or the front end application. There was no way to verify that this was a legit front end. There was a hack possible in OAuth old version. That was the only vulnerability left in the secured protocol. They fixed it basically. So now what happens is, whatever your front end is, it also adds a code challenge to some random string that it generates and passes it. That's how. And then there is a way to verify that only that particular front end will be able to verify that. So we'll see how exactly. But in case of some hacker application or duplicated front end, that will not go through. It will be prevented at one step that I'm going to show you. So another nicety is dynamic client registration. This was very important thing, because earlier we had to have one static front end or back end But then there was a need for the AI to be able to talk to any type of dynamic clients. Like you have a MCP server for Slack, tomorrow maybe another MCP server coming for other technology. So you want your any client like VS Code to be able to use any type of MCP server being talking to any type of AI agent. So it's many to many type of communication that was also not possible in the original OAuth. So we have this extension also, whereby extra endpoints are there like register. So basically on the fly we register the MCP clients and AI agents, and they are able to then talk to each other in a secured way, like following the rest of the OAuth mod protocol. But however, you have to have your registry, who you trust as a MCP server is definitely then up to you, which is why the consent form is always up there when you try to register. So now before we jump into the very details and with a demo on implementation, how it is done and how to implement in your application, we'll first talk about the options. First of all, you have KeyCloak open source solution. You have to host it yourself. It can be Dockerized also. A small instance can host up to 50k users, but beyond that, be aware that you have to have a clustered setup. So while it's a very famous solution, many big SaaS services are using it, but they have to have some maintenance cost of it when there are 50k plus users. You need a clustered setup, and basic IT infrastructure management also needed because it uses database and all those things. Especially with the clustered, management is even more. And then there is another option, by the way, Intra ID. It's also a very good option because up to 50k Active Directory objects, not the users, because users are always little than the total objects created by Active Directory. So it's basically the same Active Directory which was on-prem. Microsoft later on shifted it to Azure Active Directory, and now these days it's called Intra ID. It also gives you free OAuth protocol, by the way, and up to 50k users is free. The good thing is it's a hosted service already on the Microsoft domain, so you get all the security. Microsoft have a very good DDoS protection also, that comes also free for you. There's an initial benefit. However, be aware of the fact that it's not totally free. When you go beyond to 50k, you have to upgrade your service. So it's not a free thing, but KeyCloak is a total free solution, but then infrastructure cost you have to bear in mind. So you have to compare that. Also, Google also gives you a solution for that. And Microsoft Identity Server is also there. It was free, also open source solution. It's a library, in fact. But the problem is, a few years back, just around 2021 or 22, I believe, it became commercial actually. Now you have to pay some premium prime to the Microsoft, since Microsoft acquired it. So it's a paid library, but for the .NET, it's a wonderful solution because the code base is in .NET. So it gives you all of this plus more also. This Microsoft Identity Server gives you federation also, by the way, which KeyCloak inherently doesn't have. But when do you actually need federation? I'll explain in this video actually also. So for the sake of this demo, I have one Rust service, one .NET service, one Node.js services also, to how the token flow will happen and how the actual SSO flow will happen, and is it really safe? We are going to see that flow running. So before we talk about flow, because flow is a little bit complicated, and when mostly people see the flow, they get intimidated that it's going to be super complex. So in order for the ease of understanding, I'm breaking it into 4 parts: initial authorization, then there is a token exchange part, then there is a token refresh part. This is very important, but we'll talk about later, because the token is there, but we need to continuously replace the token. We need to shorten the span of the lifetime of the main token, so that the access window or the security gap is blast radius, or we call, is minimized. And then we have a secure way of logout. 4 sections. This is the initial picture of the access. I'll just give you a short rundown on this before I get into more detail with the code. So here basically what happens is, as I mentioned, Pixie is there. So you have a random string generated at the front end. With that, you generate a hash. Hash, as you know, basically it's a one-way function whereby you can generate a smaller string from the original string, and there is always one-way relation to it. You send that relationship challenge and the method of this has 256, by the way, the hash algorithm. You just mentioned the message. You send it to the KeyCloak, and then KeyCloak gives you back an auth code. No token is returned to the front end, by the way. and auth code is then handed over to the backend. Backend uses that auth code to fetch the tokens, the main tokens. Now the backend only gives you the access token, keeps the refresh token with itself. It doesn't give you the refresh token by default. And the access token also, it only sets as the HTTP only secure cookie. This is a very special cookie, by the way. There are two niceties to this cookie. One, JavaScript cannot access this. So you have tons of NPM models. Some of them might not be trusted even, might not be used much even. They are maybe newly introduced by some small group of people. They might be not trusted even, but that code, if it runs in your browser, it has no access to this cookie. So access token is there, but code cannot access it. Yet human can access it. But how to protect that from the human also, that factor also we are covered in this video using the secured refresh token flow. If not 100%, but I'll tell you the mechanism we are using these days in the industry these days to prevent hacks from that also, like Postman hacks and others, right? So with that said, you use that cookie token to each subsequent request, and each request is then introspected for the token validity also, because there might be the case the user is logged out by the time you are placing the API request, so that check is always there. And at the backend logout and the end logout is there. So further to that, I'll show you a little bit. We'll talk about Pixie and state. There are some certain variables. We'll come to this thing later on. So this is the flow. Now don't get intimidated. I'll first show you the demo and then we'll come to this code. So here I have some of the services running in my VES code. So here is my front end. So if notice this is front end 1 as depicted in my picture. You have front end 1, you have back end 1. This is web application number 1. This is my web application number 2. You have front end 2, you have back end 2, and some extra services also, which is Rust service and .NET service on this side. This is my KeyCloak configuration, by the way. You have to have 4 clients in the same realm in the KeyCloak. So basically each set of code, either in the front end, because each web application is what? It's just a front end. Normally you're using Next.js or maybe you're using .NET, whatever code is there, it have to split into 2 sections, front end and back end, and number of microservices that you might be having. In my case, I have 2 here on one of the application number 1. So this is my configuration. On the public side, front end 1, you always disable the client authentication because it can be any browser. You cannot enable it. You have to set to off. Standard flow is there, but you mentioned the PKC's flow is mandated. This is set for the front end only. Why front end only? I'm going to show you as well. You just set the origin URLs here. Same goes for the backend. I mean, here you have this service. Now one, here you have client authentication on. So any communication from the backend, it's secured always. And authorization is on. And standard flow for the authorization is, by the way, for the fine-grained authentication for the scopes that I'm going to discuss also. And then you have the standard flow. Same is here exactly. It's just that 2 additional microservices are here. So you have frontend1.com, backend service1.com as a backend for the frontend 1. You have frontend2.com, and then you have service2.com as a backend for the frontend2.com. So 2 applications using the same KeyCloak, and you have a user here. We'll see how it works. So we have code here, and then we have application running here. So my frontend1.com is here. I'll try to log in. It will redirect me to my KeyCloak service and will ask me the credential. I don't want to do that now. Here is my frontend 2. If you notice, this is the frontend 2. I try to log in here. It is all again asking me for the credential. Now I'll go back to the frontend 1. I'll see how the thing goes. I'll try to log in here. This is my user ID and password. I get authenticated. I place an API request to my backend, and I'll be able to fetch the result. I come to the front end too. If you notice, I'll try to log in. Now it's no more asking me for any credential. It just quickly, if you notice, it redirected me very quickly. And now I'm able to access this service too without any user ID password, because SSO is directly another indirect benefit from the OAuth. But many things went under the hood that I'm going to show you from the flowchart. So if I'm going to call the backend API, I'm able to do that. I'll come to the other Microsoft services also and explain you the purpose of that. But before I do that, let me first show you from the flow chart actually what happened under the hood. You have this user here. It basically came to the front end 1.com as you just saw, and then front end 1.com, as I press the login button, it directed me to the KeyCloak directly, just creating the small PKC challenge code with a random string as I showed you. And all it did basically, it asked the user browser to please go to the KeyCloak and get yourself authenticated. So basically it redirected the user browser to the KeyCloak identity service. It could be Azure Active Directory or whatever other identity platform you might be having. This is regardless of that. The protocol by itself is platform agnostic. It's your options. So here basically the redirection happens as the step number 2. Redirect for other authentication to the KeyCloak. Now KeyCloak, what it does at this point is, at the point number 3, it talks to the user. Now if you see, all the login related, credential related things is directly now between user and the identity service. There is nothing to do with it, either the front end or the back end. Now it's asking the user to give the credentials. User provides the credentials and user is now logged in onto KeyCloak only. And KeyCloak basically also, if you notice at the point number 3, 4 and then 5, after providing the credential, sets the HTTP only secure session cookie. Now this is a very special cookie, as I already mentioned just recently, that HTTP only means this is only accessible to the HTTP session only. JavaScript code cannot access it. Secure means it's only accessible over HTTPS session. And third thing is, basically it's also is presented only to the original issuer who is setting that cookie. Now this cookie is only between the user and KeyCloak identity service. This is another beauty of it. This is very important also to the flow. The cookie set between the user browser and the KeyCloak have nothing to do with the backend one and frontend one. Both of them will neither be able to access this. So this is where the main magic is coming from. So special cookie is set, and that session is developed between, direct trust is developed between the user and the KeyCloak. Now at the step number 5, after 5, number 6, you are redirected back to the auth code only. Now if you notice, you are authenticated, but you are not getting any tokens. All you're getting is a small auth code. Small auth code is presented to the main front end. Now front end basically, as a step number 7, if you notice here, it uses that auth code plus it sends that original verifier string also, because the front end and back end, now their communication is a lot secure compared to this part, because then there is a CORS also enabled. The front end is coming from the same backend, so CORS protection is also there. And then you send the auth code along with the original verifier here to the backend, through which you generated the hash for the PXE. And then backend in the same call basically fetches the refresh token and the access token from the identity service. So it's not your front end which is getting the tokens. If you notice, only the backend is getting all the tokens. Now backend, it keeps the refresh token with itself, only give you access token, and that access token is also an HTTP only secure session cookie. Like this relation was developed between the KeyCloak and the user. Now there's a new relationship developed between the front end and the user. Now only this front end and the user, they have a trust, and the backend. Now these session cookies is not shared with other domains. Now KeyCloak cannot access this access cookie during this session. So it's a trust between this service and this user. So this is another beauty. Now once you have this cookie already attached to the session, every request you make, like for example, if we follow by number, so hereby we are asking the backend to get the token. Backend did forward everything. It got the auth code and everything to the identity provider, and it got the refresh token, and it got the access token also. Access token only is setting to the HTTP cookie, but refresh token it's keeping to itself for the later use for refreshing the token. It's not giving that to the front end. Another magic that is happening is this auth code is also forwarded to the backend along with the original verifier. KeyCloak, what it does, it uses the same SHA-256 algorithm, then creates the hash again for that original verifier. If we get the same challenge code that was sent in the very initial flow, then it comes to know indirectly that okay, it is the same front end one. So any introspection happen or maybe man-in-the-middle attack could have happened between this communication. Auth code got leaked out, then the original verifier is still not leaked out. So we can check to see that this session is compromised. KeyCloak, what it does or your service, at any of this occasion, session will be destroyed and you will not be able to proceed with the communication anymore. That's a good thing. So once you have the cookie and the access token set, the next communication is very streamlined. You basically make any request, automatically that cookie for the access token is with you, attached to each request. You make that request. When the request net goes, and the point number 9, introspection happen. Introspection is a special point whereby you verify from the ID provider if the token given to me coming as a cookie or whatever is valid or not, because there are scenarios like user might have already logged out, or might be in runtime from the backend somewhere some logic is there. We revoked all the logins from security compromise. So that's another nicety you get. So introspection point is there with all the OAuth standard implementation, including the Azure Active Directory also. So the result of the token validation goes back to the backend one, and the backend one allows the request. And from that 11, another magic happens. A user tries to access front end 2. Now here the real beauty starts. Basically on the front end 2, you basically, again similar to web application 1, you are getting redirected to KeyCloak identity provider. Indirectly you are asking the user browser, please go and authenticate yourself from the KeyCloak again. Now here the KeyCloak, if you see after 12, 13, you are redirected, and at 14, a special thing is happening. KeyCloak senses and gets the session cookie, because I told you earlier during the start that there is a special relationship and trust developed between the KeyCloak and the user. A special session cookie was set, which only these two parties are able to see. This cookie is never presented to front end 2, back end 2, back end 1, or front end 1. Now KeyCloak can see we have a very special trust between each other. No need to add the credential again. At 15, it will just say, okay, I have this session cookie, special relation. This guy is already authenticated. I already issued him the session cookie already. Set it is there. And it is this guy, realm is also same. Now this realm is a special concept basically in the KeyCloak. All the clients 1, 2, 3, 4, 5, 6, they are in the same realm. Realm means SSO is by default enabled, single sign-on is by default enabled, trust is default enabled. If you do not want this behavior, create a special realm, second realm, different realm. SSO between the different realms, you need a federation. We'll talk about federation also, but let's not get confused at this stage. Simple key takeaway here is, if you want natural SSO, just use the same realm. And the concept is says for the Azure Active Directory also. So now here basically, if unlike the earlier session, you do not ask the user for the credential. Credential is already with the KeyCloak. KeyCloak will directly issue the auth code. Then the same rest of the PXE flow, everything will happen same. API request will get to and fro. Introspection is happening here and here also. Now these other services, as I told you, for example, if I come to this front end 2, I told you I have other microservices also. So I have this Rust microservice. I'm going to try to again invoke it. Now, as I told you that this cookie that was developed between the two services, it is not going to get shared with any other domain. Now the Rust service, it has its own domain. It is running on different ports, different URL. It's a different microservices even at the backend. So definitely that portion is not shared. So if I come to Rust service here, and if I see the logs, so you see it is saying no access token cookie found, because it's not able to fetch it. Now if I do the same request through the backend, my Node.js backend, which is the trusted backend, which had the relation developed between the user browser as a secure cookie, now it will able to call that, because now what happens is, now you see Rust eventually got the call and it returned the value also, but it happened through this service of called service 2. Let me show you where my service 2 is. You see, so basically calling Rust service. So here basically in the code, what I'm all doing is, in the service 2, basically I'm just calling the Rust service. So I'm receiving the call and just reattaching that again the to the access token to the client, and then making the request. So as simple as that. So direct call is not possible, and if I invoke the .NET microservice also from the Node.js on that is also possible, but only through the backend. So they are all able to access that code. Same like .NET call is also going floating similarly to that, all happening in the .NET. Both of these Rust and by the way .NET code, they are also very simple code. For example, this is my Rust code. This is the Rust code. So basically all it is doing is just simple request handler is there, which is just returning a value. On top of that, there are only simple middleware and then coarse checking. The middleware is doing nothing but it is just fetching that same cookie and then using that cookie to authenticate, and then it's doing the introspection. Like for example, it is just hitting the KeyCloak if the request is if the token is valid or not. So basically for each microservice to be able to talk to KeyCloak, they have to have their own client, which is why if you see 1, 2, 3, 4, 5, 6 clients are there, and they need to present, each need to present their secret. Backends, when they talk to the KeyCloak, they need to have a client secret. However, the front end, there is no secret involved, which is why if you see client authentication is disabled on the front end, but all on the backend is enabled. So that's another security you get, because backends are designated, but front end, it can be any browser, it can be any app. So you cannot enable that. So you can enable initial security from backend to the KeyCloak, which is another benefit you get. So there is a secure path of verifier going from the front end to the backend all the way to the identity provider. So beyond that, from the code itself, the flow is very simple. As I told you, we have one random string. From the random string, we create a small basically SHA-256 hash. If you see here, I'm doing the hashing. From the hashing, we are just encoding it, and then we are just asking the user, please get redirected to the KeyCloak and get yourself authenticated there, and the rest of the flow basically floats from there. And in terms of flow, let me come to invoke. You see, this is that cookie I'm talking about. It's the HTTP only secure cookie, which is only presented to this site, which is why in case of Rust, if you see, if I'm calling it, there is no session cookie attached, because it's meant for service 2 only. So through service 2, calls can be made, directly call cannot be made. And for the federation, when it comes to options, you have many. You have, for example, you can use identity manager, you could use Okta also, OAuth2.0 is there, Azure also, Entra ID, it gives you the federation support also, although that is a paid option. Earlier there used to be a ADFS server also, that was a role in the Windows server that could be used, but now it's in favor of Entra ID. It's a proper dedicated services there. So key takeaways for the secure authentication, you implement PKCE, because PKCE now I can show you one more thing, one nicety about it. What happens is I'm passing the client ID, which is front end one. This is the way for the KeyCloak to know who wants to talk to me. So you tell the browser to go to the KeyCloak, but tell him that this is my client ID. This is the identity who is directing you to issue the auth code. And then you, of course, redirect URL where to come back again, where the redirection will happen again after the getting the auth code. And then response type code, you are here mentioning that I'm opting for the PKCE flow. And then scope, as I mentioned, authorizes the fine grained authentication. So you can even minimize on the scope level. So this is another granular type of security that you get. And this is another interesting state variable. Basically, it has 2-3 purposes. State variable is basically for the PKCE, like it prevents you from the interception of the auth code. Let's suppose your front end is hacked, or some other party is having that auth code also by the impersonated app or hacked app. Then basically PKCE mechanism prevents that by adding a verifier on top of that. So verifier is only passed to the backend. If you see here, my backend call is there, only then it's getting passed as a code verifier to the backend. This state variable is also there. Basically, it has two functions. First, it lets you, in a big SPA application, it will tell you what state the original application was, or the front end was, when the authentication flow started. Second benefit, it gives you CSRF protection, because you also, in my presentation, I tried to show you that you also have two challenges. Number one is you want to definitely protect yourself from getting intercepted and auth code is getting released. You want to make sure the front end is the authentic or the genuine one. At the same time, you want to be sure that the service you are talking to is also the correct one, is also not compromised, is not the fake one. Because what happens is sometimes attacker can do half of the flow, everything is genuine, but then you are presented a link to click onto, and then you click on the link also, but the code, authentic code, was generated by some other browser. You happen to complete the rest of the flow. Now basically someone is co-owning the session with you. In order to prevent that, you have to have a code with the injected. The code is matched. If you see, if my code implementation, what I'm doing is, when I'm getting the return value, I'm always comparing it. So when I have the call returned, if the state is not same, then it means I was not the original person who initiated this flow. So you are again protecting from the CSR attack also. So basically all of this sums up into closing all the vulnerabilities. This is the reason why this protocol have been ruling for more than 2 decades, and now is the de facto for the AI agent authentication also. So knowledge of it is indispensable and it's very important. And coming back to my presentation, so here what I'm doing is, here by the way I try to illustrate in this particular slide that HTTPS introspection is also there these days. Earlier it was assumed that HTTPS traffic is end-to-end encrypted. That is actually not the case. In fact, since 2010 Microsoft had a product called, which is no more there now, is what TMG. It had a feature of HTTPS traffic inspection. So traffic was, yes, encrypted from the service up to the TMG gateway. Thereby it was re-encrypted using another certificate. People did not know it, or you do not know it. Even now firewalls are there which can do the HTTPS packet inspection, which is why you need all the PXE and state inspection. Without that, you might be leaking out a lot of details. Now we talked about realm, we talked about federation, and key takeaways: you implement PKC. Further to that, you implement CAPTCHA also for the repeatability type of attacks or creating a DOS attacks. This is the important thing. You attach nonce also for the idempotency, by the way. And then you should have immutable logging if you are working in a fintech. This is more than important. I have one video on the immutable logging also, how to implement it using Elastic. That is indispensable. If you are working for a fintech, you have to record the movements basically. And then you should have IDS IPS. That's another type of stack of solutions. You should upgrade to MFA. This is mandated. And OTP as a email is not the ideal solution no more. As you know that most of the banks are also shifting from it. They are going in a favor of this authenticator apps, which is now the de facto new standard, or the passkeys. Both are good. And then of course platform strategy, like the model of the OAuth solution, as either it's going to be a SaaS service or you're going to host it on the KeyCloak, and how you're going to scale it, and it's platform security also. And then PKC hash algorithm, that is already I discussed. S256, the good part is you can upgrade it also. 384, 512 also is up to you, but by default S256 is there. And S256, by the way, is already quantum ready. It's too much of a long string. That quantum number of qubits that are available to date, they are not able to hack it. So you are covered on that part also.